Hello, today I want to explain you about my research. And then before we start, please allow me to introduce myself. My name is Ramanda Fadhillah. Here I am as a presenter from Electrical Engineering, 11 Maret University. And then uh, the title of my presentation is Current Voltage Analysis of High Voltage Plasma Discharge on Inverter Boost Kit 15 kV. Okay, we start from introduction. Plasma technology nowadays is a very major technology in everyday life because of its benefits in various types like industrial, health, environment, etc. What is plasma? Plasma is the first state of matter, which can occur when the temperature or energy of a gas is raised to allow the ionized gas atoms to make the gas release its electrons, which normally surround the nucleus. And then to produce plasma, we need high voltage. And then so this research was conducted to measuring the current voltage to see the characteristics of the voltage and current of the media that used to make a plasma. And then current and voltage are also used to see the type of plasma. Then we analyze the value to determine the electric charge value. And then we come to literature study. Based on the amount of current and voltage that occurs in the plasma event, further analysis can also be carried out on the electric charge and capacitance at the time of the plasma event. The equation is Q equals to integral current multiplied by the derivative of time. And from this equation, it can be concluded that amount of electric charge depends on the amount of current that occurs in units of time. And this analysis method is also used in arc discharge plasma to get the value of power consumption in this stage gap. And the methods, the figure is the schematic of Inverter Boost Kit 15 kV. The source used that voltage source from 3.7 volt DC lithium battery. The transformer with a resistance coil ratio of 1 divided by 1000 taken in open circuit. And then plasma event is generated at atmospheric pressure in air ambient. And then this is the schematic of measurement. This for current sensor we use ACS 712 with per ampere with sensitivity 185 millivolt per ampere. And then the sensor is use the principle of contact on a wire which is identified. And then for the voltage measurement, we use CT2700 high voltage digital multimeter probe for secondary winding with ratio 1000:1. And then the data is taken around 10 seconds with an accurate per data is 51.25 milliseconds. Plasma event is turned off at the second 5 till second 7. Yeah, then this is the result. The result is secondary voltage and secondary current. For the secondary current, we calculate the secondary current value using primary current value with the formula below. And then on the secondary side, voltage The voltage jumps to approximately 57 kilovolts in positive notation and 47 kilovolts in negative notation. The largest current value is 0.905 microampere with the base current at zero point 0 ampere. And this is the result of electric charge, which we show with histogram graph. Based on the graph, the electric charge value with range 0 to 1 multiplied by 10 to minus 12 column is negligible because the data value obtained when there is no plasma event. And then the ionized charge particles are the value of electric charge at plasma event on the electrode. It's shown in figure 3b, which in the right side, it shows that the ionization process is continuous. And then the result of calculating that we calculate the secondary current value. The peak of current value means there is plasma event. The table shows the peak value of the secondary current value for a 0.2 second period from second 20 and from second 2.1 till 2.3. Based on all the data value on the table, the average distance range for electrodes is about 5 mm. This comparison data value means that each data occurs at the same time. And that means when the discharge gap, or we can say the distance between the electrodes increase, the value of capacitance will decrease, as you see. And then we come to conclusion. From the result of the predicted secondary current value, can be concluded that the discharge type of inverter boost kit 15 volt plasma is corona discharge type. And then the electric charge value depends on the secondary side current value, which means all the calculation data are based on the secondary current value. And then the capacitance value affects when the discharge gap change. The average of discharge gap value is around 5 millimeters. When the discharge gap increase, capacitance value will decrease. Okay, it's all for me. Sorry if any mistake. Forgive me if any mistake that I've made. Thanks for your attention.